Now in section 5.2, we played around with the definition of a logarithm, and then we kind of noticed some inverse properties for that and some other properties that kind of showed up, like the log base b of b to the k is k, the log base b of 0 is impossible, the log base b of negative numbers is impossible, stuff like that. So now we're going to expand on those ideas with more properties of logarithms. Now the first is basically the definition again, that the log base b of a is equal to c if and only if b to the c is equal to a, which means you can switch back and forth between the two, which we were already doing in section 5.2 anyway. Alright, so what we're going to do here is we're going to write these in exponential form. They're currently in logarithmic form because they have logarithms in them, right? So we're going to rewrite it using that definition right there, which you just have to know cold. I'm sorry, but that's just it. So 6 to the 3 is equal to 216. That's all they wanted. They just want it rewritten in exponential form, so with an exponent. All right, now for the next one. K is our base, so it becomes the base of our exponent, to the w equals t. And we're done with that one as well. All right, now we can reverse the operation. We can say, okay, if it was in exponential form, I could rewrite it in logarithmic form. So let's see here. So this is the log base, so right, log base, and the base of my exponent, which was 3, becomes the base of my logarithm of 243 equals 5. Cool, that's logarithmic form. Oops, I better box it because it's the answer. There we go. And then over here, the log base p of q equals r. Done with that. All right, so the equation log base b of a equals c is the logarithmic form. B to the c equals a is the exponential form. And either form can be used when you're trying to solve an equation. Sometimes you'll have to switch from one to the other and backwards. All right, so let's get down here into nitty-gritty. We're going to use that property to solve some problems. All right, so we've got the log base 5 of x equals 4. And you think, I want that x. Okay, well, the only way to get rid of the logarithm at this point that you know of is to rewrite it. So the log base 5 of x equals 4. That's logarithmic form. Rewrite it. 5 to the 4 equals x, which means x is equal to 625. Done. Not hard at all, right? As long as you keep in mind the logarithmic form and the exponential form, it shouldn't be too bad. All right, now this one's going to be a little bit more work, so let me do this. So this is going to be b to the 7 is equal to 95. All right, now we want to get b by itself. So remember what we have to do here. We're going to have to raise both sides to the 1/7 power, because you basically want to get rid of the 7th power over here, right? This will disappear, and so will this, and things will be grand. It's technically the 7 on the bottom. There we go. Oops. Sorry about that. There. But if you do it to the left, you have to do it to the right. Oops. It's called exponentiation. You're exponentiating both sides. You're raising both of them to the same exponent. And then you just make a calculator find this. 95 to the 1/7. Just don't forget to use parentheses around your power, sorry. So it should be squiggly equals, because it's not exact, 1.9166 or so. No plus or minus because this was an odd power anyway, right? And besides that, you can't have a negative base to a logarithm anyway, so it's got to be the positive one. All right, let's do more of them. Now, for C and D, you've got a little bit of an issue. You want to rewrite them, but they're not clean. They're not logarithm equals number. Like this was logarithm equals number, logarithm equals number. These are not like that. So you're going to have to take some time and get it so the logarithm's by itself. So it's log base 27 of x plus 5 equals 7. So the first thing you want to do is subtract 5 from both sides. There we go. So we'll get 3 log base 27 of x, oopsie, of x equals 2. All right, then we're going to divide both sides by 3 because we want to get the plain logarithm. We don't want that 3 in there. So I'm going to divide both sides by 3. That will cause this to drop away because 3 divided by 3 is 1. So that's gone. And it leaves you the log base 27 of x is equal to 2/3. All right, well, you still need to solve this for x. You need to get x by itself. So you do 27 to the 2/3 equals x, like that. Well, that means x is, okay, we've done this before, but you could do this with a calculator, but we've also done it in our head before. 27 to the 1/3 is 3, 3 to the 2 is 9. So this one's 9. Again, you could check me with a calculator. I don't have a calculator right this second. All right, we're done with that one. Now let's look at this one. So it's 2 log base 2 of 5x minus 3 equals 10. Now what a lot of students try to do is they try to multiply 2 times the 5x, but that's not correct because this is 2 times the logarithm of this stuff. You can't just multiply 2 in. The distributive property only works with multiplication and addition. It doesn't work with logarithms. So the only option you have is actually to divide both sides by 2 to make the 2 disappear. Okay. There we go. So you'll get log base 2 of 5x minus 3 equals 5. All right, now we can rewrite it. 2 to the 5th is equal to 5x minus 3. So that means 5x minus 3 is equal to 32. And then I'll add 3 to both sides. Do it over here, do it over here. You'll get 5x is equal to, hold on one second. 5x is equal to 35. Then divide both sides by 5, and you'll have it. X is 7. Okay, done. I'll just show this division right there. All right, we're all done with those. All right, so let's see what's on the next page. The power property. All right, I don't think we'll be able to get through all of these, but we'll start it. So the power property is saying that, look, because of the way logarithms operate, that if x is greater than 0 and b is greater than 0, then you can bring the power p down in front. And you don't realize it now, but this is actually really a good thing. Okay, so this is, let me put this one to you. This one is log base 7 of x squared. That's equal to 2 times the log base 7 of x. Done. Right? I just wanted to modify these to use the power property. That's all we're practicing at this point. That's going to come in really handy in a bit. I know you don't believe me, but I swear. Right? So this is x to the 3rd. That's 3 times the log base 5 of x. I'm just bringing the power down in front. Good. Again, that's just using that property up there. Now, it didn't say anything about x and y, but it's the same idea. As long as they're both to the 3rd power, then you can do that too. So you can say, okay, it was the log base 3 of xy to the 3rd. Then I can make that 3 times the log base 3 of xy. I can bring the 3 down in front. Now this one might seem different, but it's actually not very much different at all. It's the log base 7 of xy to the 3rd. I know it says x to the 3rd, y to the 3rd, but let me show you. This is really x to the 3rd, y to the 3rd. But that's the same thing, there we go, as this. Hold on. Okay? It's because of the property. So remember the property that we learned because of, let's see, it was b to, oh, here it was. It was ab to the p equals a to the p times b to the p. It was the one that we learned in 4.1. So because of that, that means that I can take xy to the third, excuse me, x to the third, y to the third, and make it xy quantity to the third. And that means that I can make it log base 7 of xy all times 3. I can bring this 3 down in front. So I can take it to the outside, put 3 out there, and then bring it down in front. Now that's very different from what we can accomplish for E and F, because if you look at E and F, they don't have the same powers like D did. When you look at D, it's x to the third, y to the third, and that's what allowed us to make it xy quantity to the third, like here in the center. But over here for E, this isn't going to be possible yet, right? So it's not possible yet. There's something else we will learn that'll help us do this. But at this point, it's not possible yet because x and y are not to the same powers. And actually that's the case over on F as well. Right? Which is why I wanted you to get this warning down. When you have a letter in there or anything else that's not raised to the p power, you cannot bring the p down in front. If it's x is only to the p, but this front number is not, that's no good to you. There's nothing you can do with that. Not yet. There is something we can do, and it's addition. So we'll learn something. We'll learn, oops, in 5.5 to help with this. Oops, my dog is barking. Hold on one sec. All right. We'll deal with that later in 5.5. And let's stop right here because the next example all ties together, and I don't think I'll have enough time in a few minutes to do it. So let's pause right there, and we'll pick back up for the next page.